There's a star out there right now, spinning faster than any machine we've ever built, whipping around at over 700 times per second. So fast its surface moves at a measurable fraction of light speed. It doesn't shine the brightest. It doesn't burn the hottest. It isn't nestled quietly in some distant corner of the cosmos. It's here, in our Milky Way, a cosmic ticking time bomb that NASA monitors around the clock. And if it slips by even a whisper, a single extra gram of mass, it won't explode in a blaze of glory. It will vanish, collapsing into a black hole before we even realize the lights have gone out. Imagine a sphere 20 kilometers across, smaller than most cities, but weighing 2.4 times the mass of our Sun. That's PSR J0952 0607, the fastest spinning, heaviest neutron star ever discovered. It grew this extreme by tearing apart a companion star, siphoning its matter in a searing, spiraling torrent of plasma. With each atom devoured, it gained speed, much like an ice skater pulling in her arms. And with each rotation, gravity squeezed it tighter. Now it perches on the razor's edge of collapse. One more feast, one more surge of spin, and neutron pressure can't resist gravity's pull any longer. In a heartbeat, it will cross the Tolman-Oppenheimer-Volkoff limit and flip into a black hole, masking its light and slipping into shadow. What's terrifying is that this collapse would be silent. No brilliant flash, no shockwave, just the abrupt end of its rhythmic radio pulses, beats that have echoed across space for decades. In a single moment, the galaxy's lighthouse dims, and a newborn black hole hides behind its event horizon, warping space and time without a whisper. If that seems bleak, consider the magnetars, the silent assassins of the neutron star realm. They spin more lazily, yes, but their true weapon is magnetism. Picture a magnetic field so intense it tears atoms apart, ripping electrons from nuclei and shredding matter's very structure. One such magnetar, SGR 180620, in 2004, unleashed a gamma-ray flare so powerful it overwhelmed satellites across our solar system, even from 42,000 light-years away. That outburst momentarily outshone every other X-ray source in the sky. Had it been just 10 light-years closer, it could have incinerated Earth's ozone layer, leaving our world exposed to lethal solar UV radiation. No explosion, just a flash of energy so immense it would silently sterilize everything in its path. These stars aren't fiction. They are real, and they lace the galaxy like unseen landmines. We've clocked neutron stars hurtling through space at over 1,500 kilometers per second, fast enough to leave the Milky Way itself. If one ever aimed its beams toward us, even from the orbit of Jupiter, its gravity alone would tug at our planets, unsettling orbits, stirring meteors toward Earth, triggering volcanic eruptions, and setting off global earthquakes. And then comes the radiation, X-rays, gamma rays, charged particles that punch through our magnetic shield, stripping away ozone, frying satellites, and bathing the sky in unnatural aurorae, an eerie, luminous alarm in every direction. Yet, in this crucible of destruction, planets exist. PSR B1257+12, a pulsar 2,300 light-years away, hosts 3 rocky worlds larger than Earth, orbiting in wildly elongated loops. How did they survive the supernova that spawned their host? Some likely formed from fallback debris, supernova ejecta that cooled into a dusty disk and coalesced over millions of years. Others may be fragments of a companion star, shredded and then pulled into new orbits. Rogue planets drifting through space can even be captured by a pulsar's gravity. Against staggering odds, these survivors cling to life's potential, perhaps deep underground, shielded by miles of rock or locked beneath icy shells, awaiting the slightest hint of warmth or energy to flicker to life. Now imagine witnessing one of these stars finally snap. Models predict a brief burst of gravitational waves, ripples in the fabric of space-time that detectors like LIGO and Virgo are poised to catch. Picture the moment, an almost imperceptible tremor, a fleeting whisper in the cosmos marking the final heartbeat of a neutron star as it collapses into a black hole. It would be the ultimate testament to nature's raw power, a real-time chronicle of a celestial giant's quiet death, and our greatest insight into the laws that govern matter under unimaginable pressure. Should this keep us up at night? A shiver of awe? Yes. Panic? No. Even if PSR J0952 06007 collapsed today, we wouldn't learn of it for 14,000 years. Its light takes that long to reach us. Magnetars, though deadly, burn out over mere tens of thousands of years, making them rare. Our sun sits in a tranquil corner of the galaxy. Earth's magnetic field and atmosphere combine to create a sanctuary amid cosmic chaos. But never forget, space doesn't follow human notions of safety or warmth. It obeys pressure and collapse, spin and magnetism, gravity and radiation. It pushes matter to absolute extremes and then beyond. And even now, somewhere in the dark, a star may already be teetering on the brink, spinning itself apart, feasting on its companion, inching ever closer to oblivion. When you next gaze up at the night sky, remember, those pinpoints of light aren't just tranquil beacons. Some are spinning death machines. Others are silent magnetic monsters lying in wait. And one of them, maybe right now, could be taking its last, invisible breath before the cosmic switch flips, and a new, unseen monster emerges from the void. In the vast theater of the universe, we are both audience and participant. A reminder that in the grandest scales, our safety is a fleeting miracle, and the cosmos is always ready to rewrite the rules.